So, hi guys, welcome to day 7 of 21 days of code. So, let's wait for some viewers to join. Am I audible to everyone? Okay, so hi everyone, welcome to day 7 of 21 days of code. So, first of all, is my voice audible to everyone? Uh, just quickly reply in chat, all those who are watching. Then we will discuss the topic and the problems that we are going to solve. So Pooja says yes, and uh, yeah, cool. So on day 7, we are going to discuss problems based on 2 pointers. problems based on two pointers approach. And so also you can see that we have completed 6 days, right? We have completed our 6 day streak and it's the 7th day. So let's begin the problem solving. And I have randomly chosen three problems in the interview bit section for two pointers question, and the problems will be sorted by the companies in which they were asked for, and also the difficulty and the time asked to solve that problem. Okay, so let's begin by the question named as sort by color. Okay, so yeah. So you are given an array with n objects colored red, white, or blue. Sort them so that objects of the same color are adjacent with the colors in the color in the order red, white, and blue. Here are some integers 0, 1, and 2 to represent the color red, white, and blue respectively. And this means that if the input contains only three integers, which are 0, 1, and 2, and we have to modify the array so that it becomes kind of sorted, right? Because all the zero appears first, then the one, and then the two, all the twos, right? So pretty straightforward question, and a straightforward trivial answer is just sort the array, right? But here's a special note in the question that library sort function is not allowed. So yeah, that's fair enough, because sort function would have worked if the elements in the array can would have been anything, right? From 1 to 10 to the power 9, it can be anything ranging from all the ranges, right? But here it's specifically mentioned that the elements are 0, 1, and 2, so it's quite possible that we could have uh, used a optimized approach rather than the n log n version. So, okay, so we have three elements here. So what else we can do? We can also use counting sort here, right? Counting sort is basically just count all the zeros, count all the ones, count all the twos, and yeah, and just create a new array where all the zeros would be placed first, then all the ones, then all the twos, and that's it. The question is solved, right? But again, this is a sorting technique. This would have worked on any element. So what specific can we do in the case when we are given only three unique integers, which is 0, 1, and 2? Yeah. Okay. So how can we start about thinking this? Okay. So in the input array, we have 0, 1, 2, 0, 1, 2, right? And we have to modify the array so that it becomes sorted. This means that if these three integers are only we can we can kind of divide our answers into three regions, right? And these three regions would be the left region, which is all zeros, the mid region, which is all ones, and the rightmost region, which is all twos, right? So, uh, which is all twos, right? So what we can do is that we can uh, we can have a start pointer, which is which points to the start of the array, and we can start filling the start of the array with all the zeros we encounter while traversing through the array, right? And we can also have an end pointer which points to the end of the array, and we can start filling the end pointer we can start filling the array from the end. Okay, and as we encounter 2 as we traverse through the array, and once we have filled the s once we have filled the end, we will automatically have ones in between, right? So it seems like a good enough approach. So we can start coding the solution, right? So first of all, I will save the size of the array inside uh, a variable n, right? And then I'll then I will have a point to the start of the array and a point to the end of the array. And please note here that we have to make all the changes in place. This which means that uh, we have to change the input array itself, as we cannot return the array, the final array, right? We cannot return the obtained array. So we have to place zeros at the start and two at the end, right? And we will also have a loop counter which will iterate over my array. So this means that I'll have a while loop here, right? And this I will basically go on till the end of the array, till e, because uh, for all the indexes after e, we would have filled the two already, right? So we don't need to change, or we don't need to edit the twos after it, right? So this means that right. So if a of I comes out to be 0, right? If a of I comes out to be 0, then what I can do easily is that swap I can swap ai and as, which means that ith element is 0 and it should be placed at the start of the array. So I will quickly swap the ith element with the one that was placed at the start of the array, and then I will increment the start, because I want all the indexes before s should have all the zeros inside it, right? Now in the same way, if ai comes out to be 1, in the same way, if ai comes out to be 2, sorry, if ai comes out to be 2, then I will quickly swap this element with the end of the array, and I will decrement my e, because I want that all the indexes after e should have 2 in it, right? And now this looks like a decent enough approach, because since as soon as I encounter 0, I will swap ai with as and I will increment s, and as soon as I encounter 2, I will swap ai with the end of the array and I will decrement the end of the array, right? So this seems to me like a decent enough approach, and let's try to test our solution. Okay, so our solution fails for some trivial test case. So this seems to be a big test case to debug. So let's see that. Let's try to see where our code will actually fail. So yeah, so I'm pretty sure that this if condition will place all the zeros before the index s, right? Okay, now let's look at this index, this if condition. So I'm saying that if I encounter 2, then I'll swap the end of the element with the element which by e with the 2 element itself, right? Okay, okay. Uh, but think of this test case, like think of this test case. So what will happen here is that what will happen here is that once I am at this index, once I am at 2, it will swap 0 with 2, right? Because e was pointing at 0. So it will swap 0 with 2, and then I will be incremented to this position, right? But this is not the required answer, because I need to segregate all the zeros first, then 1, and then 2, right? So this means that it is quite possible that this a of e comes out to be 0, right? This is not a good approach. Yeah, you can change, you just need to change a small bit of thing here, and that is that you don't need to increment I at this position, because it is quite possible that it's being replaced by 0, right? So once this is done, yeah. So once this is done, so even if even if AE was zero, right? Even if AE was zero, then AI would get zero, and we are not incrementing I here. So basically, this loop will again run for the same value of I, right? So we have passed the sample test case here. Let's try to submit the solution. And okay, so we have passed all the test case here. Yeah, we have passed all the test case here. So yeah, it's a decent enough approach among, because we are using two pointers, the start pointer and the end pointer, right? And the only thing was that the only catch was that we it's quite possible that A of E comes out to be zero, and we wanted that it is swapped with we wanted that it should be swapped with one, but it quite possible that it comes out to be zero. So the simple solution was the that we don't need to increment our I remains the same, right? So I guess that everyone has got the solution. Just quickly reply with yes or no. Oh yeah, so Umang got it. Everyone else? Mm, okay, so yeah. Yeah, so I can move on to the next question now, right? And the next question says that you are given n non-negative integers, which are a1, a2 up till an, okay, where each represents a point at the coordinate I, comma ai. Okay, so there are n vertical lines, and they are drawn such that the two endpoints of line I is at I, comma ai and I, comma 0. Okay, so this means that there is a vertical line, and at each for each index ai there is a vertical line I, comma ai. I is the x point, I is the x coordinate, and ai is the y coordinate, right? And okay, so I comma 0 is the start of the vertical line, and I comma ai is the end of the vertical line, or you can say the top of the vertical line. Cool. So we have to find two lines which together with the x-axis form a container such that the container contains the most water. Okay, so your program should return an integer which corresponds to the maximum area of the water that can be contained. The maximum area instead of the maximum value sounds weird, but this is 2D plane, so simplicity, you cannot slant the container. So vertical lines, right? You have a bunch of vertical lines placed at I, comma 0, and their height is a of I, right? Their height is a of I. So you have to find two vertical lines. Let's say that one is of this length, one is of this length. You have to find two vertical lines with the maximum area between them, so that he can so that he can we can save the maximum area of water inside it, right? Okay, so we have an input which is 1 comma 5 comma 4 comma 3. Okay, and the output is 6 here. Why? Let's see that why the output is 6 here. So 5 and 3 are too distant apart. Yeah, 5 is at, if we take zero based indexing, 5 is at 1 comma 0, and 3 is at uh, 3 comma 0, right? So they are too distant apart, and the size of the base is 2. So yes, the size of the base is 2, and the height of the container is minimum of 5 comma 3, which is 3 itself, right? So which means that if this is 5, let's say that this is 5, and let's say that this is 3, and there is a two unit distance between them. So what would be the height of the container? The height of the container would be the minimum of these two heights, right? And it would be 3. So basically the total area would be 3 times 2, and this comes out to be the maximum area here, right? And okay, so the only question that I am not able to understand here is that why aren't we considering this 4 here? We are not considering this 4 here because because okay, we just need to find two lines. Okay, we just need to find two lines, and this does not involve the lines between them, right? We just need to find any two lines which together with the x-axis, right? Which together with the x-axis only find is able to have a container, form a container that contains the most water. Okay, so this means that we have to find two vertical lines such that the area between them is the maximum. So the problem boils down to this, right? So we can think of a straightforward brute force solution. Just take all the pairs I comma j, right, and find the maximum area that you can get. You can find the maximum of all the areas that you can get once you choose all the possible pairs I comma j, right? But this won't be enough. Like, this is an n square solution, so can I think of an optimized approach? Okay, so let's see. So basically you have to maximize the area of the container, right? So area of the container is given by the width of the base and the height of the container. Okay, so the area depends upon two things: the width of the base and the height of the container. So what we can do is that let's iterate upon one. Let's iterate upon the width and see what is the maximum height that we can get, so that we get the maximum area, right? So if you understood my approach, I am saying that let's say our width is 4. Okay, so if our width is 4, the only possible two vertical lines are 1 and 3. So the area possible is 1 times 4, right? Because min of 1 comma 3 is 1, right? So so now let the width be 3 itself. So if the width is 3, then the two possible vertical lines are 1 comma 4 or 5 comma 3, right? Sorry, width is, if the width was 3, then the possible vertical lines would be 1 comma 3. Sorry, because we are counting the difference between the indices. 1 is at 0 index and 3 is at 3 index, right? So the width would have been 3. Now let's see, let's see the solution for width equals to 2. So for width equals to 2, we would have two possible vertical lines pair, and that would be 1 comma 4 and or 1 comma 4 will give a height of 2, because 2 times min of 1 comma 4, and 5 comma 3 would give an area of 6, because twice of min of 5 comma 3. Okay, so we up till now we have got an area of 6. So now let's again decrement the width. So width comes out, so now the width is 1 itself, and width being 1, okay, so if the width is 1, then 1 comma 5 will have an area of 5, right? 5 comma 4 will have an area of 1 comma 5 will have an area of 1, sorry. 5 comma 4 will have an area of 4, and 4 comma 3 will have an area of 3, right? So still the maximum area remains to be 6 itself. Okay, so yeah, so this is again an n square approach, but maybe thinking in this direction, we can optimize the approach, right? And how can we do that? Okay, so what further optimization that we can do is, so let's think about think about what let's think about the case when our width was 3. So when our width was 3, our only possible vertical line pair was 1 comma 3, right? Okay. So when our width became 2, our option became either 1 comma 4 or either 5 comma 3, right? Which means that if my 1 is start, if my 3 is end, right? And after and for width being 2, which is decreased from 3, I have two options: either take 1 comma 4, right? Ignore 3, either take 1 comma 4, or ignore 1 or take 5 comma 3, right? So what would be my best option? So my best option would be what? My best option would be to remove 1 from the picture, right? And this is the case because out of 1 comma 3, 1 was responsible for being the smallest one, right? So it's so after removing the smallest one, it's quite possible then that the next element is it may be possible that the next element is greater than that element, right? So it's quite possible that my answer would be increased since my width has been decreased from 3 to 2, right? My width has been decreased from 3 to 2. So our next to in order to maximize the area, our goal is to increase the height, right? So if we have to increase the height, so here is the start, here is the end. So we have two options: either to decrement the end or to increment the start in order to obtain a vertical line pair for width equals to 2, right? So my choice would be that I would increment that thing which was responsible to be the smallest one in the previous case, right? So if I take the example here, and my example would be that let's say my start is at 1, my end is at 3. So in the next iteration, or I would say that when I will decrement my width to 2, so I will increment the start here because if I will increment the start, my min of these two will now change to 3, right? If I would have decremented my end, my minimum of these two would have remained the same, which was 1 earlier to, right? So there would not have been any improvement in my maximum height of the container, right? If I would have decremented the end. So what I can do is that I can increment the start here and my end remains the same. So for the width 2, I will have an area of 6, right? And for the next iteration, I will decrement the end. I will decrement the end. So now my minimum height becomes 4, but my area is 4 itself. So the maximum area would be 6. Yeah. So now that we have reached to a decent enough approach, where if if this is incorrect, let's see that where we can make some improvements. So let n be the size of the array, right? Let the start pointer be 0, and let the end pointer be n minus 1, right? Let the end pointer be n minus 1. So yeah, and we will initialize our max area with 0 because we would be go on updating the max area variable with the maximum area that we can obtain so far yet, right? So okay, so what we can do here is that while start is less than equals to end, our area the area that we can obtain the area that we can obtain is e minus s, which is the width, right? Why width? Because width is the difference between the index, right? So this is e minus s, and now we will see the height of the vertical line. So height of the vertical line would be the minimum height of the start or end of the index, right? So once we have obtained the area, so we can once we have obtained the area, we can update our max area variable, right? Okay, now we have updated the max area variable. Now what we can do is that now we have to either increment or decrement the pointer. So this says that if the minimum of ASA was AS, right? If the minimum of AS comma A was AS itself, this means that I have to increment the start, right? Else else means that the minimum of AS of A was A. This means that I have to decrement my end variable, right? And so in this way, I would have the maximum height possible for all the widths allowed, for all the possible widths allowed, and I would hence calculate the, and I would keep on updating the max area variable with the area obtained using this, right? So let's see that if it passes the sample test case. So not the answer, but the max area. Okay, so this solution passes the sample test case. Let's try to submit it. Okay, cool. So we have passed this solution and we have also maintained a 7-day streak. Congrats, just 14 more days to go. Okay, so as you can see that this question has a fairly simple code. This question has a fairly simple code, but it was decent enough, right? From logic point of view, you can say, right? And this question came in, was asked in Facebook, Google, Amazon, and Adobe. So this is quite an important question, right? Okay, so let's move on to some other question, and this seems like a difficult one. So let's pick the let's pick this question. So any doubts up till here? uh, Maybe we are moving a bit fast, but if you have any doubts, you can send me on chat. Meanwhile, I will go through this question. Okay, so you are given an array of ones and zeros, right? And you are given an integer m, which signifies the number of flips allowed. So find the position of zeros, which when flipped will produce the maximum continuous series of ones. For this problem, return the indices of maximum continuous series of ones in that order. Okay, so you are given an array of ones and you are given an integer m, which signifies the number of flips allowed. Okay, so you are allowed an at most m number of flips, and flips are from zeros to ones. Okay, so you have to find the position of zeros, which when flipped will produce the maximum continuous number of ones. For this problem, return the okay. For this problem, we have to return the indices of the maximum continuous series of ones in order. Okay, so with this means that if this is our array, this means that if this is our array, and we have m equals to 1, so we can either uh, flip we can flip this or this or this, right? Since we are allowed to flip at most one bit, or you can say at most 1 0, right? And so we can flip this, or we can flip this. Okay, So the output is 0, 1, 2, 3, 4. Why? Because once we flip this, the maximum uh, continuous series of ones is this, and this has uh, just a second. This has 5 elements, right? Starting from 0 to 4. Okay. So the question also says that if there are multiple possible solutions, we have to return the sequence which has the minimum start index. Okay. So if there are if the maximum continuous series is of 5 and there are several indices where this continuous series can start with the length of 5, so we have to return the minimum start index. Okay, fair enough. So let's see that how can we start this problem. So basically a very brute force solution is key for all the possible 2 raised per m cases. 2 raised per, I'm talking about 2 raised per m because pick all the zeros and either you will switch to 1 or you will flip them to 1 or you will not flip them to 0, and change the array according to that, and hence find the maximum continuous series of 1. So that would be kind of a 2 raised per n or brute force approach. So that won't be acceptable, right? But let's think of how can we optimize it. Okay, so how can we optimize it? Okay, so let's start from the beginning of the array. So once we start from the beginning of the array, and so if we encounter 1, we won't do anything. We will just increment our pointer, right? Because agar 1 ho, so that's useful for us. We don't have to flip any bit. But if we encounter 0, then we have to flip the bit and decremental n, right? So once we reach to an index such that we have exhausted all our m's, we are exhausted all our number of flips. So that is the maximum continuous series of ones that we can obtain from the start of the array. Okay, and so let's see that what happens after that. So once we have started from the beginning and we have exhausted all our possible flips, so we have if we have exhausted all of possible flips, so is actually uh, this entire array is actually uh, my possible continuous series of ones. But after that, what I can do is that let's say that next position is 0, and we up till this we have exhausted all our flips, right? So what I can do now is that I can start kind of incrementing, or I can start incrementing our start pointer from which is previously pointing at the start of the array. I can increment my start pointer such that up till that position that my or you can say that up till that position that my such that my number of possible flips get updated, or you can say that I will I will increment the start up till I get the first 0, and I would ignore that first 0 that I want to flip, so that I can flip these zeros further possible, right? So my this is kind of a sliding window approach you can think of. Why sliding window approach? Because let's say this was my initial possible array and we have 0 here, uh, which we cannot flip, right? So what I will do is that I will decrease the size of the window up till uh, I reach to the first 0, so that I can increment my possible flip and I can use that flip to flip this bit, right? And once we have incremented the flip from by reducing the window, we can start increasing our size of the window, and again we will reach to that index up till which we have exhausted our flips, right? So as we are increasing, decreasing, and changing the size of the window, we will maintain the start and end of the continuous series of ones that we have obtained up till now. Yeah, so fair enough. We have reached to a decent enough solution. So what we can do is that we can start to code this. So here n is the size of the array, okay, and my window will be represented by two variables, start variable and end variable. S equals to 0 and is equals to 0 initially, because initially my size of the window is 0. I will keep on increasing the size as I proceed with the solution, okay. And I will also have my answer begin and answer end, and answer begin and answer end will save the starting and the ending pointer of the maximum continuous series of ones possible, okay. So I will iterate until my end reaches the end, until my e reaches the end of the array, because that will be the maximum, that would be the end of the window that I can expand till, right? So okay, so now first is the time of window expansion, right? So we can do window expansion here. So how can we expand our window? Acha, I will also maintain the number of flips that I have done up till now. Okay. So how will I maintain? How will I expand the window? So I will keep on incrementing the end variable, and I will do so until until flips are actually less than equals to b. Right? Until flips are less than equals to b, because I don't want the flips to exceed b. Right? And if our a is 0, what I can do is that I can increment the flip, because if it is possible to flip the uh, current index, then I will flip it, because I want to create a maximum chain of ones, right? And I will increment e, right? So this was window expansion, and then we will talk about window contraction. And window contraction would be that while start is less than e, right? While start is less than e, and flips are basically and flips are greater than b, right? So while start is less than e, why? Because I want the start of the window to reach up till the end only, and flips is greater than b, because I want the flip to reach back to b again, right? So that I can flip the further bits, okay. And if a of start, since we are reducing the size of the window, so if a of start equals to 0, then I can simply decrement by my b variable, and I can increment my s variable, because I need to contract my window, right? And okay, so we have done window expansion and we have done window contraction. So now what we can do is that we can write some few lines to maintain the answer. And what we can do is that if flips are less than equals to b, yeah, we want that flips would maximum be b, and also if e minus s is greater than answer n minus answer s, and minus I want the maximum length of the array, right? I want the maximum contiguous array. So E minus S is my current window, and answer E minus answer S is the maximum window that I have obtained up till now. So if E minus S is greater, then simply, and this should be answer begin. Sorry, this should be answer begin, and answer begin is start. Answer begin should be start, and answer end should be end itself, right? So so this will keep on this will keep on updating my answer as we try to expand our window. And now we will quickly save our answer. So I will have answer, I will start from answer begin. I will move up till answer end, and I will update this, and answer dot push back will be equals to I itself. So we have created our answer array, and I will return the answer. Yeah. So let's see that if this passes the solution. No, it does not. So let's see that how can we debug it. So uh, looks like that we have missed one element. Looks like that we have missed one element, and the only reason for that is uh, maybe that I am missing equals to here, because answer E denotes the end of uh, answer E denotes the end of my maximum contiguous array of ones. So let's see that if it gets submitted. Yes, it has passed the trivial test cases. So let's see that if the solution is correct, and the solution seems fine. Yeah, great. And Superman for me, thank you. Okay, so I guess we are done with our half an hour live stream, and we are done with our three problems based on 2 pointers. So any doubts up till now? After this, I end the stream. Just quickly tell me any doubts and any questions for me. Basically, reply. You can reply in chat. Umang, Priya, Pooja, any doubt? Hmm. Yeah, window compression. Yeah, sure. So, the window compression is something like this, that I will increment my start variable up till I will increment my start variable only up till the end, right? I will increment my start variable only up till my end of the window, and I will increment it up till I will increment it up till my flips is greater than b, which means that up till I have not encountered any zero up till now, right? So after just see to this. Let's say that after this loop is finished, it's pretty sure that my flips will come out to be greater than b, right? Because I have put a condition here that flips are less than equals to b, right? So if this loop gets broken, or if I am outside the loop, then either e is less than n, or uh, either e is greater than equals to n, or my flips become greater than b, right? uh, so in this case, while my flips become greater than b, I have to pull back my flips to to being equal to b, right? And how is it possible? It would be possible by window contraction, right? And while window contraction, we will continue it up till I get to the first zero while incrementing the s, right? Okay, so I will get to the first zero while incrementing my s, and as soon as I have incremented my s, I will decrement my flips variable, and I will increment my s, and I will be out of this loop, right? Okay, so Adil has got it. So this was his problem. Adil asked that, can you explain the window compression? So that's why I was going through it. Yeah, cool. So anyone else with any doubts? Or I guess I'm done with the lecture. I guess the lecture is over, or the live is over. Uh, just quickly reply, Adil, Umang, Priya, Pooja. Anything left? Any doubts? So this was day 7 of 21 days of code. So be tuned in. There are 40 more days left, and all the best for your stay in 21 days of quarantine and lockdown. Thank you.